Hello, I'm Chayan Vinayak, and in this video we are going to discuss iterators, and we would also take a look at some of the basic iterators provided with OpenMaya, and using one of those iterators we would extend our command or plugin which we wrote in the previous chapter, and using that iterator we would print out the complete hierarchical structure of a scene. So let's get started. So the first thing is, what is an iterator? Iterator is an object that enables the user to traverse a set of data. What does that mean? For example, we have sets of data, multiple sets, connected to each other. In computer programming language, that means it's kind of a linked list. But if you don't understand what is linked list, don't worry about it. Consider it as a linked set of data. These are all data. So what would be an iterator? Iterator would be an object that would traverse or read this set of data one by one. So in the first step it would read this. In the second step it would read this. In the third step it would read this. Fourth step this, and last step is this. So on user's instruction it keep on moving to next set of data until this chain ends. So now we understand what is iterator. In the second step we would discuss some of the basic iterators available in OpenMaya. So first, MIT Dag, model iterator Dag. The iterator, I would hide this, that works on a DAG. So if you have a DAG, direct acyclic graph, or I would understand it in this way, this iterator would iterate this complete direct acyclic graph. So the first it would go here, here, and now there can be two ways of iterating it. First it might go here, here, and here, or it might go here, here, then here, then here, here, and here. So we would understand later how we would switch to these two different techniques, but that's the overall idea of MIT DAG, model iterator DAG. Second thing is MIT dependency graph. So this iterator will be used to iterate the dependency graph. So if we have the dependency graph nodes or the plugs connected, it would traverse this complete dependency graph. These are plugs, these are nodes. So MIT dependency graph is used to iterate the dependency graphs. I would keep labeling them. So this is MIT DAG. This one is MIT dependency graph. Third is MIT mesh edge, and this iterator is used to iterate the edges of a polygon surface. E3, E4, E5, E6, E7, dot 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 dot. So MIT mesh edge is used to iterate the edges of a polygon surface. MIT mesh edge. The fourth is MIT mesh vertex, and as the name states, it should be used to iterate or traverse the vertices of a mesh or of a polygon object. V1, V2, V3, dash dash dash, which is MIT mesh vertex. Fifth type is mesh polygon. So the name is not that clear, but what this iterator would do, it would traverse the faces of a polygon mesh. 1, 2, 3, 4. MIT mesh polygon. The sixth type of iterator is MIT surface CV, and this iterator works on the NURB surface, and it works on the CVs of NURBs. So these are some of the basic iterators provided with OpenMaya. There are a number of more iterators, and there is one more very important iterator which is called as MIT Geo, which is a geometry iterator, and we will discuss that iterator in the chapter or in the tutorial of deformers. When we would discuss deformers, we would discuss that iterator. So now we would go and extend our plugin or the command which we wrote in the previous chapter, and we would use one of the iterators, which is MIT Dag Iterator, and using that we would print out the complete scene hierarchy. So now we would start writing the code for using Dag Iterator. The first thing I'm going to do is import maya.openMaya as OpenMaya. The second thing I'm going to do is I'm going to create a Dag Iterator. So this is the variable name, and how am I going to use or create Dag Iterator? I would say OpenMaya dot m uppercase I uppercase T Dag, and it needs two arguments. One, what kind of iteration do you want to do on this iterator? So in the previous slide, when we were discussing the MIT DAG, we saw that there can be two ways of iterating this tree. One is going to this node, this node, this node, and this one. Or from here we can jump to this one. So there can be two ways of iterating a DAG. In this example, we would use OpenMaya dot MIT DAG dot K depth search or first search. So what is K depth first? To understand this, we would understand two different types of searches or search algorithms. So let's get back to our board and start understanding two different types of search algorithms. So we are going to take a look at two different type of search algorithm. One is depth first search. Second is breadth first search. So first we would understand what is depth first search. So if we have a tree or a DAG and we have to traverse it, and if we are using the depth first search, what we would do is we would first go to A, and then because there is only one node connected to A, which is B, so we would go to B. Third is we would go to C, which is on the left hand side of node B. Now in the depth first search we want to keep going at the deepest level, so from C we will go to E. So now there is no depth after E, so we would come back to C. After that we would go to F, which is at the same depth level of E, but it's connected to F. After F we would come back to C, come back to B, then we would go to D, and then we would go to G, then we would come back to D, and we will go to H. So in this way we have traversed the depth first. So we have traversed the depth first. So the traversing would be A to B to C to E to F, then D, then G, then H. But if we take a look at the breadth first search, we would go from A to B. To understand the breadth first search, we can divide our tree into different levels, and that's how the search would work. So we have divided our tree into 4 different levels. So first from A to B, and then B to C. Instead of going to E, we will go to D, because we have divided the tree into levels. After D we would go to E, F, G, and H. So the traversing would be A to B, C D, E, F, G, and H. So now we understand what is depth first search and breadth first search. So we will go back to our code and continue writing it. So in this case, we used the depth first search. The second argument we use here is for filtering. If we want to filter out any kind of object, for example, if I just want to read the lights of the scene, I would provide here the lights. But in this case, if I do not want to filter anything out, I would say openmaya.mfn.k invalid. So invalid means the filtration is disabled. I don't want to filter anything out. Whatever I read in the scene, I want to iterate through it. So now we have imported OpenMaya and we have created a Dag Iterator. The second thing I am going to do is to create a Dag node function set. So Dag node fn for function set, that's my variable name, and to create that I will call openmaya.mfn dag node. It would give me a function set of a dag node. Alright, I have created a function set of the dag node now. So Maya Dag Iterator comes with a couple of functions that are so helpful to use an iterator. For example, if we have to check if the iterator has traversed the complete set of data, we can check that. We can also check at what level of depth it is. So if it is from A to B, this is second level of depth, third, fourth. So in this way, using the functions provided with the Dag Iterator, we can check the depth level, and we can also check at what object it is iterating at this point. So if the iterator is at a object, we can find out the name of that object. So now we would start using those functions comes with a Dag Iterator. So the first thing, I'm going to write a while loop in which I would say while not Dag Iterator dot is done. So this function tells me if the iterator is done traversing the set of data. So if it has traversed the complete graph, it would be true. So this while loop will run until this condition is true. Alright. The second thing I'm going to do is I want to know at what object the Dag Iterator is working on. So I would call it as current object, and I would have to find out Dag Iterator dot current item, which would give me the name of the current item. It exactly doesn't give me the name, but it would return an M object pointing to the Dag node of the item which the iterator is working on. For example, if the iterator is working on Dag node A, if an iterator is on A, which is the Dag node, the current item would return me an handle, mObject handle. Pointing to the current Dag node. In the current object, we would receive an mObject. The second thing I'm going to do is I want to find out the depth at which the iterator is working on. So I would use a function Dag Iterator dot depth. So now I have two things. One is the name of the object or the mObject pointing to the Dag node. Second thing is the depth. At this point we have a function set which is Dag node fn, which is empty. It's just a function set. None of the data is provided to it yet. So we would provide it an mObject. And which mObject we would provide it? That mObject at which the iterator is working. And we know that in the current object is a mObject on which the Dag object is currently working. So what we would do next, Dag node fn dot set object. So it would set the input object for that function set, which is current object. So now we have current object as input of this function set. The next thing is I want to read some information from this mObject. mObject itself is not so sufficient, so that's why we attached a function set to that mObject, and now we are going to use that function set. So the first thing I want to know is the name of the node which the iterator is working on. So the name would be read by dag node fn dot name. Then I want to know the type of the node, which is read by directly mObject. We don't need the function set for that. Dot API type string. If I would just type API type, it would give me the code, which would not be that readable. That's why I want to use API type string, which would give me the name of the type. And that's the path, like it would give me the full Dag path of that node dot full path name. Alright, so now we have the name, type, and path of each object. Then we also want to shift our iterator. Dag Iterator dot go to the next set of data. So that's the basic structure of a iterator, getting the information from it. What basically we are doing is we are creating an iterator, and until it finishes iterating, we are moving it to next set of data. And while shifting it to the next set of data, we are reading some information from that data set. So we have read the name, type, and path. Now we want to print it out because we want to see it, and we want to see it in the way we can read the hierarchy. So we would do one thing, because we know we have a variable called as depth, 0 to depth. I would run a loop from 0 to the depth, which would print out a long arrow. Alright, or instead of printing it out, I would save it in a variable, and I would call it as print out. Control C. Control V. Alright, and I also want to print out the name I'll give some space so that it's more readable, and then I would like to print the type of it. We can use the path as well. We can add plus path, but at this point I'm not going to use it. So that's our code, and for example, I have created a scene which I would open, and I would show you the hierarchical structure of it. It has different objects. At the top most level, it's p cube 1, and there is p cylinder 2 inside it, p cone 3, p plane 4, and p pipe 5. And we want to print out the hierarchical structure of that. So let's run our code and see what it does. So there is an invalid I in range. Okay, now run it. Okay, we have not given the instruction print out. Run the code again. Alright, here is our hierarchical structure. So here we see is this is the complete printout, and here is your DAG. So these are the basic objects which comes with a new Maya scene. Here's a perspective camera, top camera, front, side, universal manipulator, and cube compass, and ground plane, and this is the world object. So here's the actual printout of the objects which we created. So the first thing is p cube 1, which is a transform node, and I would enable the shapes so that you can see the shape nodes as well. Then there is a p cube shape 1 inside p cube 1. Then there is a cylinder shape, cone shape, plane shape, pipe shape. So there is a transform node first, and then there is a shape node, and that's how we print the complete hierarchy of a scene using the Dag Iterator. The next thing would be to integrate this code in the plugin which we wrote in the previous chapter. So to extend the plugin which we wrote, we would first load the script file of the plugin, And here we see that there is a doIt function which previously printed doIt, and now what we would do, we would copy the code which we just wrote for checking the Dag Iterator and paste it here in the doIt function. And I would do the proper indenting, and instead of doIt I would print scene hierarchy. And instead of the plugin command I would give it name print hierarchy. So this would be the name of the command. Alright, now save the script as print hierarchy.py. Alright, now I would open a new tab and I would say import maya.cmds as cmds, and there is a command to load plugin which is cmds.load plugin, and now I would give the path of file. Either we can use double backslash or front slash, and the directory is plugin, and the file name is print hierarchy.py. So it has loaded the print hierarchy plugin. Now to run this command we would say command.cmds. the name of our command and parenthesis. Execute that, and here you go. Here is complete scene hierarchy. So that's how we write plugins, we use Iterator and do multiple things.